So for this last video segment, what we're going to look at is just derivatives of some really interesting functions. Some of you might say ugly functions. We're going to see combinations of product rule, quotient rule, chain rule, trigonometry, you name it. Anything that we've covered at this point is fair game. So let's look at this first function. F of theta is equal to 1 divided by 1 plus e to the negative theta. Some people see this as a quotient rule. Let's do it one time using our quotient rule. And then I'll show you how you can do this using the chain rule. If it's the quotient rule, then f prime is going to be low, 1 plus e to the negative theta, times d high, derivative of the 1 is 0, minus high, times the derivative of the low. Derivative of 1 is 0, plus the derivative of e to the negative theta is e to the negative theta times negative 1 over 1 plus e to the negative theta squared. I want to simplify this a little bit. 1 plus e to the negative theta times 0 is just 0. I have a negative 1 times e to the negative theta times negative 1. That's the same thing as e to the negative theta over 1 plus, e to the negative theta squared. That's the derivative. You should be feeling good about that one. Sorry, it's a little messy at the end. That's how you can do it using your quotient rule. But I also like to think of this as a chain rule because the original function, f of theta, since it's 1 over all of this, I can write that, not using calculus, just using algebra rules, as 1 plus e to the negative theta, the whole thing to the negative 1 power. Now I have a baby and I have a mama. Oh, the mama. F prime of theta, if it's all of this to the negative 1 power, you bring the power down, 1 plus e to the negative theta to the 1 less power, times the derivative of the baby. The derivative of 1 plus e to the negative theta is, well, derivative of 1 is 0. Derivative of e to the negative theta is e to the negative theta times negative 1. I can clean that up. I have negative 1. All this to the negative 2 power is the same as 1 plus e to the negative theta squared times e to the negative theta times negative 1. Well, I've got a negative 1 over here. If I multiply it with that negative 1, I get positive 1. And what do I get? E to the negative theta over 1 plus e to the negative theta squared. Same answer. Use your quotient rule, use your chain rule, doesn't matter, same answer. I love it. All right, let's look at this one. G is equal to the secant of x. This is not one that many people in the room have memorized. But we do have some ways to get around this. I'll tell you, this one is actually a quotient rule. If you remember that secant is 1 over the cosine, there it is. That should be a much easier problem for us to do. It's your quotient rule again. So G prime is going to be low cosine of x times d high 0 minus 1 times derivative of the cosine is negative sine of x over cosine of x squared. Low d high minus high d low, low low. Cosine of x times 0, that's 0. Negative 1 times negative sine is sine of x over cosine of x squared. Beautiful. Done. That's it. Or is that it? This would be a perfectly acceptable answer. But I want to uncover a nice little derivative rule here. I can also write this as sine of x over cosine times 1 over cosine. Take a moment to convince yourself that that's true. Sine over cosine squared is the same as sine over cosine times 1 over cosine. Now, why did I do that? Because sine over cosine is the tangent. 1 over cosine is the secant. So what we've just shown is that the derivative of the secant is the same as the derivative of the secant is tangent times secant. For those of you good at memorizing, there's another one. You could go through and develop your derivative for cosecant, for tangent, for cotangent. You can do this for all of them if you remember those reciprocal identities. All right, moving on. All right. Still, more derivatives. H of t is the natural log of e to the negative t minus t. Natural log. I see it. There's my baby. The way we take the derivative of the natural log of just plain old x is 1 over x. So if I'm going to take the derivative of the natural log of a baby, it's going to be 1 over the baby times the derivative of the baby. How do I take the derivative of the baby? Derivative of e to the negative t is e to the negative t times negative 1. Minus the derivative of t is 1. All of that times 1 over e to the negative t minus t. You could clean that up if you wanted to and get negative e to the negative t minus 1 over e to the negative t minus t. That's your derivative. Okay. Next one. F of t equals e to the negative 4kt. What I meant to write in here is that k is a constant. So k is a number that's not going to change times sine of t. If I want to take a derivative, I have to recognize that I have a product. I have two functions being multiplied together. So how do I find f prime of t? I'm going to find f prime using my product rule, which is the derivative of the first, derivative of e to the negative 4kt times, leave the second one alone, plus, now we leave the first one alone, times the derivative of the second one. The derivative of e to the negative 4kt, we're over here now. Derivative of e to a power is e to that same power times the derivative of the power times sine plus e to the negative 4kt times the derivative of the sine cosine. Depending on the problem, you might stop there, or you might look at this term over here and this term over here. You might recognize that there is a common factor of e to the negative 4kt, which you can pull out, you can factor it out, leaving you negative 4k sine of t plus cosine of t. That's also the final answer. So you could stop over here, you could stop over here. Both of those are perfectly legitimate final answers.